Okay, can you see this diagram? Delta G versus x1. So in this
Yes,
case,
sir.
that the upper curve, which is concave facing upwards, is mobile over the entire concentration range. Okay, now we'll see why the mathematical thing for that. If I look at this diagram, it's the same thing. I drawn it separately. It's delta G versus x1, and if I draw a tangent to this curve at different points, what you'll see is that the slope here is negative, here it is 0, and here it is positive. Correct? This is negative, this is 0, and this is positive. बराबर है ये delta G versus x1.
Yes, sir.
Okay. So now, if I take the derivative and I plot d delta G by dx1 from this curve, upper curve, I draw d delta G by dx1 versus x1 again. So what I'll get is this is negative. So this portion will be negative from here till 0. Then it crosses 0 and then it becomes positive. This portion is positive. Okay. So if I plot d delta G by dx1, the shape of the curve is starting from negative, crosses over at 0, and then it becomes positive. Any doubts on this one?
No, sir.
Okay. So now, if I take again tangent to d delta G by dx1, I'm taking tangent here. Suppose I take tangent here. This is positive. This is also positive. This is also positive. So all the tangents along the curve will all be positive because the angle is always less than 90 degrees. Right? So any point I take this tangent on this d delta G by dx1 versus x1, the slope is going to be positive. Is that correct? Is that okay? Is that agreeable to you? Yes, no, don't know, don't understand. कुछ तो आंसर आना चाहिए.
Yes, sir.
Right? So slope is positive throughout this curve if I take a tangent. So, क्या बोल रहे हैं? Was there any comment? Difficulty है क्या तो बताओ. Before you proceed. नहीं है. So okay. If there is no comment, let us
Sir, वो
proceed.
slope कैसे change हुआ वो बताना.
कौन सा slope?
मतलब वो डेरिवेटिव के पहले और डेरिवेटिव के बाद.
Delta G versus x. कौन से ग्राफ की बात कर रहे हो? D delta G versus x और D delta G by dx1.
D delta G by dx.
ये प्लॉट किया ना, ऊपर से हमने लिया स्लोप, राइट? इनिशियली दिस वन इज यहाँ पर नेगेटिव है. आपको स्लोप पता है क्या होता है?
Yes,
स्लोप
sir.
पता है? हाँ, स्लोप पता है कि स्लोप क्या होता है?
Yes, sir.
Yes, slope, if it is less than 90 it is positive, if it is more than 90 and between 90 and 180 it is negative. ये बेसिक है, ज्योमेट्री से आता है ये, राइट? So if I am taking this one, इसमें है slope is angle is more than 90 degrees, so it is negative. Angle is 0, it is, so slope is 0, and angle is between 0 and 90, it is positive slope. That is coming from geometry, right? So I have taken this value and just plotted it. D delta G by d. Slope of anything, delta G versus x1. Slope is what? d delta g by dx1. स्लोप इज डेरिवेटिव, ये आपको पता होना चाहिए, राइट, मैथ्स में से. So if I take a tangent and take a slope of that tangent, that gives me the derivative of that function. So this is nothing but I'm taking delta g and plotting d delta g by dx1. तो स्लोप प्लॉट किया मैंने, यहाँ पर नेगेटिव है, यहाँ पर जीरो हो गया, क्रॉस हो गया, और यहाँ पर पॉजिटिव हो गया. समझ में आया?
Yes, sir.
Okay. So now if I take the slope of this curve again, I'm taking the slope of this curve, d delta g by dx1 versus x1. This is again x1. यहाँ पर पॉजिटिव है, सब जगह पॉजिटिव स्लोप, बिकॉज एंगल इज बिटवीन 0 and 90 डिग्री सेंटीग्रेड, 90 डिग्रीज, राइट. सो स्लोप कहीं भी टेंजेंट लिया तो पॉजिटिव आएगा. ठीक है, ये बराबर है.
Yes, sir.
ओके. सो डेरिवेटिव ऑफ डी, यस
सर वो जो मेन वाला कर्व था ना ऊपर, वो रिपीट कर सकते हैं?
डेल्टा जी वर्सेस एक्स.
हाँ
डेल्टा जी वर्सेस एक्स, ये कर्व जो है, ये कर्व की बात कर रहे हैं ना.
हाँ, वो जो
This curve, if you see, if I take a tangent here on this side, this angle is going to be between 90 and 180. The slope is negative on this side. बराबर है? Is it okay or not okay?
सर वो जो कल मिक्सिंग वाला बताया था ना कि when two solutions are mixed तो डेल्टा जी जो आता है वो वाला.
वो ठीक है, बाद में देखेंगे. First, let us look at this one. Why the derivative, second derivative has to be positive or negative? I'm explaining that part. So mixing वाला
Okay,
बाद में देखते हैं. We go back to that. Okay, that's what you want. We'll look at that also. But first, let us look at the condition for stability, which we said that second derivative should be positive. That's what I'm explaining right now. Okay, is that okay?
yes sir.
So this is negative on this side, 0 here, and positive on this side, right? So if I plot that, I take the derivative d delta g by dx1 versus x1. It's going to start negative and it's going to cross over at 0, and then it's going to become positive. Is this okay? Is this understood? Any doubts on the d delta g by dx1 versus x1 curve? Okay, if there are no questions, then if I again take a tangent to this curve, plot a tangent to this curve at different points, you'll see that the angle is always less than 90 degrees. So the slope is always going to be positive anywhere on this curve, wherever I take the tangent. You can see that, right? कहीं भी tangent लिया तो it is always positive. Is this understood? That means if I take the tangent to this curve, that means I'm taking a second derivative, or d square delta g by dx1. That's what it is now, right? So if I plot d square delta g by dx1, I'll get all positive values because this is now above 0. These are yet positive here, it's positive here, it's positive here, it's positive here, everywhere it is positive. So I'll get a curve like this, which is always above 0, always positive. So d square delta g by dx1 square is positive when the system is stable. It is observed that the concave upwards curve, that is for a stable system. Is this understood? Any questions or doubts on that? First part, d square delta g by dx1 square versus x1. ठीक है? Okay, there are no questions. Let's proceed to the second part. Now, if the curve is something like this, जो नीचे वाला कर्व था हमारा डेल्टा जी वर्सेस एक्स, जो यहाँ से टर्न हो रहा था, दिस वाज टर्निंग लाइक दिस. वी आर टेकिंग दिस पोर्शन विच इज कॉन्वेक्स अपवर्ड्स, राइट. कॉनकेव अपवर्ड्स जो है वो पॉजिटिव रहने वाला है, टी स्क्वायर डेल्टा जी. तो आपने देखा, राइट, कहीं भी कॉनकेव अपवर्ड्स है तो इज गोइंग टू बी पॉजिटिव, डी स्क्वायर डेल्टा जी बाई डी एक्स वन स्क्वायर. But when it is convex upwards, it's going to be ulta behavior, right? If I take this convex upwards and I draw a tangent everywhere to this curve in this region only, right? So here it is positive, here it is 0, and here it is negative. So the curve, यहाँ पर tangent on this part is positive, यहाँ पर flat है, वहाँ पर 0 है, और यहाँ पर negative होने वाला है. ठीक है? Any questions on this part? This part, this curve. ठीक है. There are no questions. Then if you draw tangent, take this thing, tangent को हमने प्लॉट किया हमने d delta g by dx1 square dx1. Okay, network speed has gone down. That's why you're not able to see that below second curve. वहीं पर हो गया है, अटक गया है. Okay, are you able to see this diagram now?
Yes, sir.
दिख रहा है क्या?
Yes, sir.
Okay. So if you can see this diagram, ये जो second curve है, जो convex upwards था, and we have taken tangents at different points in this curve. यहाँ पर positive है in this portion, यहाँ पर 0 है और यहाँ पर negative है, right? So if you plot slope of this delta g by x, d delta g by dx1 plot किया versus x1, so we'll get something like this in this region between these 2 points, x1 values. It will be positive here, यहाँ पर 0 हो जाएगा और यहाँ पर नेगेटिव हो जाएगा, ठीक है? Is this okay? This is understood? So it is positive here, 0 क्रॉस ओवर करके यहाँ पर नेगेटिव हो जाएगा, because that's how it is turning, right? It is going up and then going down. And if I plot tangent to this curve at different points, यहाँ पर और यहाँ पर, तो यहाँ पर angle is between 90 to 180, so it is negative slope. यहाँ पर भी negative slope है, यहाँ पर भी negative slope है, because angle is between 90 to 180 degrees. So everywhere on this slope, on this curve, d delta g by dx1, the slope is negative, right? So if I plot d square delta j by dx1 square in this region, it is going to be all below 0, because this is all negative. ठीक है? So this curve is unstable in this region only. In this region, it is unstable. It is stable in the other regions. यहाँ पर stable है और यहाँ पर भी stable है. So in the region where it is convex upwards, it is unstable. And here it is d square delta g by dx1 square is negative. And that's what we said is the condition of instability. ठीक है, समझ में आया? Is this understood? So it's not that it is unstable throughout the composition x1 0 to 1. It is unstable only in that portion where the curve changes shape and becomes convex upwards. Any doubts, questions on this part, stability? Okay, if there are no questions, then we'll move to second part, which Dikshita, what was the question now? Dikshita,
सर वो कल जो ग्राफ दिखाया था
कल वाला graph. Okay. Yeah. What is the question in this graph?
सर वो थोड़ा रिपीट करना.
Yeah. So if you take say two mixtures, suppose I take A and B. Composition is XA and XB, right? And if I mix these two solutions in different proportions, right? It could be 100 ml, 100 ml, it could be 50 ml, 50 ml, it could be 50, 100. Different proportions में mix किया मैंने. So what I'll get is, if I mix it, I'll get the composition on this line which is joining A and B, right? And the mixture composition जो भी रहेगा, it is based on how much is the volume of A and B, right? So volume of A will be this given by this length of this arm, and volume of B will be the length of this arm. The lever arm principle है. That's what you learn in physics, right? If you are sitting on two sides of the seesaw, right? तो उसमें क्या होता है? The force or momentum is proportional to your weight and the distance. यहाँ पर क्या था, ऑपोजिट साइड में हो जाता है, बिकॉज यू आर टॉकिंग अबाउट हाउ इज इट मूविंग अप एंड डाउन. सो दिस ए एंड बी जितना ज़्यादा रहेगा उतना ये इधर शिफ्ट हो जाएगा टुवर्ड्स बी, और ए जितना ज़्यादा रहेगा वो टुवर्ड्स ए शिफ्ट हो जाएगा. Right? If I take more composition of A, suppose 0.1 and 0.9, right? 0.1 and 0.9. And if I mix equal volumes of two, the mixture composition will be somewhere in between, right? Material balance से पता चल जाता है. But if I take more of composition B, then the mixture composition will be closer to B. If I take more volume of A, mixture composition will be closer to A. So it is proportional to this arm length, opposite on the other side. That's what I said yesterday. Is that understood? Dikshit, any question on that? Is that what was your question?
Yes, sir, got it.
So if it is understood, now let us move to the next part. Stability देख लिया हमने. We have seen equilibrium also. Now let us see equilibrium. How do we actually apply? Now let's move to phase equilibrium in single component systems. Ultimately, we have to see not just single component, we have to see multi-component. We'll see that also, but we go gradually. One by one, we define equilibrium, condition for equilibrium, then we define condition for stability, then we move towards phase equilibrium in single component, then we'll see multi-component systems. Okay. So if there are two or more phases of a single component, for example, water, we have seen example of thermos. If you put hot water in thermos, there will be some vapor, which will have some water vapor in it, and you'll have liquid water at whatever temperature you put in. Right? The phases can exchange mass with each other. The overall system is closed. There is no mass exiting the system, right? From thermos, there is no water evaporating or going out of the system. It is contained in the system. And if you assume perfect insulation, then there is no heat loss also. In reality, it doesn't happen like that. There is always some heat loss. But if you assume ideal condition, ideal insulation, then there is supposed to be no loss of uh, energy from the thermos, right? So it is closed. There is no mass transfer and there is no heat transfer, right? So equilibrium between vapor and liquid phases of a single component at constant temperature we are considering. So criterion of equilibrium for closed system we have seen yesterday, right? dG is equal to 0. Right? So if you write this for both phases A and B, there are two phases A and B. So dG of phase A plus dG of phase B is equal to 0. Right? So total system dG is summation of dG of A plus dG of B. Right? So free dG of A and B are free energy changes of phases A and B. Since each phase is open, because from liquid to vapor, liquid can vaporize or vapor can condense. Right? Change in its free energy due to change in temperature and pressure and moles of component. We have seen this, right? Fundamental property. dG is equal to VdP minus SdT plus summation of GI bar dNi or mu I Ni dNi. Right? So if you apply equation 2 to phases A and B, what we get is dGA is equal to VA dPA minus SAD dTA plus GA dNA, and for phase B, dGB is equal to VB dPB minus SB dTB plus GB dNB. We get two equations for two phases A and B. Is this okay?
So,
Can I move forward? नोट्स हो गया तो बताओ मेरे को, देन आई कैन मूव फॉरवर्ड. और क्वेश्चन है तो पूछ सकते हैं अभी. ओके. So if I take at constant temperature and pressure, dt is equal to 0 हो जाएगा. This will be 0 and dp will be 0. Right? So dt is equal to 0 and dp is equal to 0. So what I'll get is dga is equal to ga dna and dgb is equal to gb dnb. Now the system is closed as a whole. You can apply equation 1. What is equation 1? Equation 1 is total dgb. dg is equal to 0. So we can add dg is equal to ga dna plus gb dnb is equal to 0. Any questions on equation 3? Okay, but since the system is closed, if there's a what you call liquid vaporizing, if suppose 1 mole of liquid vaporizes, so it is -1 for liquid phase, but the same mole will go to the vapor phase, so it is +1 for the vapor phase. So dna plus dnb is equal to 0 because the system is closed, nothing is going out of the thermos or the system. So total mole change for A phase plus total mole change for B phase is equal to 0. Right? That means dna is equal to minus dnb. So now we can substitute this equation dna equal to minus dnb in equation 3, and what we'll get is ga dna minus gb dna is equal to 0. And if you take dna common, what you get is ga minus gb in bracket into dna is equal to 0. Or you can say ga equal to gb. Any questions on equation 5? No questions? So this is the condition for phase equilibrium. Ga equal to Gb. So free energy of phase A is equal to free energy of phase B. Then there is equilibrium. That means when two phases of the same substance are in equilibrium, the molar free energy is same in each phase. So if you consider boiling water in equilibrium, change in free energy for equilibrium processes, we are considering reversible. Evaporating a mole of water is delta G is equal to delta H minus 3 delta. We have seen this before. Right? At constant pressure, delta H is equal to Q. And since the process is reversible, Q is equal to TdS or T delta S. Right? So therefore delta G is equal to 0. Same thing, in another way we are showing that. So Ga is equal to Gb. Any questions on equation 5 and subsequent part? Devendra, is it clear to you? Hello?
Yes,
Can
sir,
you?
it is clear.
Okay. So can I move forward now? Are the notes done or you need more time?
Yes, sir. Done.
Okay. So for vaporizing 1 mole of liquid, delta G is equal to G of vapor minus G of liquid, two phases, vapor and liquid are in equilibrium. So G of vapor minus G of liquid is equal to 0. Therefore, G of vapor is equal to G of liquid. We've seen that. G equal to Gb. And if we put G in terms of fugacity, G is equal to RT ln F plus C. And for GA equal to GB, you can put RTLN FA plus C for A phase. You got RTLN FB for B phase plus C. RT will cancel out, C will cancel out, and what you get is F of A is equal to F of B. So this is another criteria of equilibrium. So Gibbs free energy has to be same in both the phases, and fugacity has to be same in both the phases.
सर
Yeah.
सर ये जो कंडीशन है जीवी इक्वल टू जीएल वो सिर्फ क्लोज सिस्टम में है क्या सभी सिस्टम
Closed system के लिए ही है. We are talking about closed systems only. And you'll see that in chemical engineering mostly it has closed systems.
यस सर ओके
रिएक्शन होता है क्लोज सिस्टम में होता है, बाद में ठीक है होता है. वी आर गोइंग ग्रेजुअली बिल्ड अप कॉम्प्लेक्सिटीज. अभी एक क्लोज सिस्टम कंसिडर कर रहे हैं. देयर इज नो चेंज एक्सचेंज ऑफ मास विद द सराउंडिंग्स और एनर्जी विद द सराउंडिंग्स. ठीक है.
यस सर
Okay. So any questions on phase equilibrium single component system? Okay, so if there are no questions, then we'll go to next part. Clapeyron equation. And then we'll go to multi-component systems. So Clapeyron equation exam में आता है बहुत बार. So it says that derive dp by dt is equal to delta h by t delta e from equilibrium. So we consider two phases A and B in equilibrium. So we have GA is equal to GB. If the temperature and pressure are changed infinitesimally, that means reversible processes, without disturbing equilibrium, the change in free energy is same in each phase. So dGA is equal to dGB. थोड़ा इधर change होगा, थोड़ा उधर change होगा. जितना इधर change होगा उतना उधर change होगा. So in phase change, work is only expansion work. So we can write dG is equal to VdP minus SdT, that we know from our derivations before. So for each phase we can write, or for each phase we can write dGA is equal to VA dP minus SA dt, and that is equal to dGB is equal to VB dP minus SB dt. Right? So if you take it dP on one side and dt on one side, what we'll get is dP is equal to dP into bracket VA minus VB equal to dt into bracket SA minus SB. And if we divide, we'll get dP by dt is equal to SA minus SB upon VA minus VB. That is nothing but delta S by delta V. Any questions on equation 2?
सर वो डेल्टा एस जीरो नहीं हो सकता क्या, क्योंकि डीजे इज इक्वल टू डीजीबी.
हाँ,
सर वो समझा नहीं कि डेल्टा एस फाइनाइट क्यों है, डीजे इज इक्वल टू डीजीबी है ना.
जीरो नहीं है ना, लेकिन what we said is G equal to GB, right? So जितना भी चेंज होगा A phase में उतना B phase में चेंज होगा. It is not going to be zero. It doesn't say that there is no change in free energy. There is change in free energy of phase A. The same free energy change is there in phase B. System का total dg is equal to zero. We are talking about two phases which are part of the system. So it is not zero for each phase separately. It is zero for the entire system which is closed.
सर क्योंकि हमने इधर सब्ट्रैक्शन किया ना, एस ए माइनस एस बी.
SA minus SB is not zero. When you say DGA zero हो जाएगा, DGB, that means you are saying delta S is equal to zero. It is not the case. Entropy is always changing. राइट? अगर लिक्विड से
Okay,
वेपर
sir.
में वाटर वेपोरेट हो गया वेपर में तो वॉल्यूम चेंज होगा, राइट? इफ सम वाटर इज वेपोरेटेड, लिक्विड का वॉल्यूम थोड़ा चेंज होगा, वेपर का वॉल्यूम चेंज होगा. So delta S is not zero, delta V is not zero. Any doubts on that? dg for the system is zero, not for each phase individually. Right? दोनों फेज मिलाकर जीरो है, तो जितना ए का चेंज होगा उतना ही बी का चेंज होगा. ओवरऑल इट इज जीरो, बट दैट डजंट मीन दैट ए फेज का जीरो होगा और बी फेज का भी जीरो होगा. नो, दैट्स नॉट द केस, बिकॉज कंपोनेंट इज गेटिंग ट्रांसफर्ड फ्रॉम वन फेज टू अनदर फेज. वाटर वेपोरेट होके वेपर में जा रहा है. So there's a till equilibrium is reached between A and B. If you take thermos and this put hot water in it, right? So initially, if you put half, if you fill it half with water, right? Hot water. Initially, what is happening is the space above the water, when you close the top cover of the thermos, space above the water is air at room temperature, right? But now what will happen is that the liquid water and the air, which is at the, above the water, will have some equilibrium or will reach equilibrium. Some water will be transferred from the liquid to the vapor. So when you open the thermos, what you will get is hot vapor, hot air also. Because some water is already evaporated from the liquid to vapor. So transfer हो रहा है, but it is not going outside the system. The system as itself, by itself, is not, it is closed. So G of A is changing, G of B is also changing, but it is changing in the same way or same quantity. समझा गया?
सर क्योंकि यहाँ पे इक्विलिब्रियम कंडीशन है तो सेम होगा ना, वो नहीं समझा.
इक्विलिब्रियम कंडीशन G equal to GB है, right?
हाँ.
Right? तो G equal to GB, तो अगर थोड़ा चेंज होगा, सपोज थोड़ा चेंज हुआ, मास ट्रांसफर हो गया, तो जितना चेंज होगा A का उतना चेंज होगा B का भी ना. Suppose G equal to GB equal to 10 है, suppose, right? I am just taking the number, right? But because of mass transfer, now GA becomes 9. What will GB become? GB क्या हो जाएगा?
सर वो प्योर कंपोनेंट है ना, तो मास ट्रांसफर होगा क्या?
होगा ना, क्यों नहीं होगा? Equilibrium कब होता है? When there is driving force, right? When I put hot water at say 70 degrees centigrade in thermos, right? The air above it is at 25 degrees centigrade. Is there equilibrium between these two now? What are the conditions of equilibrium? क्या देखा था हमने conditions of equilibrium? We had derived it, right? What are the conditions of equilibrium?
सर वो एंट्रोपी इंक्रीज रहती है,
हाँ,
हेल्महोल्ट्ज यानी डिक्रीज, एंट्रोपी इंक्रीज होती रहती है.
एंट्रोपी इंक्रीज होती है, डेल्टा जी कम होता रहता है. और दूसरा क्या था? इक्विलिब्रियम पहले भी निकाला था, राइट? टेम्परेचर शुड बी सेम, राइट? और क्या होना चाहिए? देखा था कि नहीं आपने? थर्मल इक्विलिब्रियम, मैकेनिकल इक्विलिब्रियम एंड थर्मोडायनामिक इक्विलिब्रियम. तो वी टॉकिंग अबाउट ऑल, राइट? टेम्परेचर डिफरेंस है तो होने वाला है ड्राइविंग फोर्स इज देयर, राइट? थोड़ा सी प्रैक्टिकल करके देखो ना. यू हैव टेक अ थर्मोस एंड पुट हॉट वाटर इन इट, नॉट completely fill it up say 50% of it, then see what happens. When you fill it up with 50% hot water at 70 degrees centigrade or 80, whatever, 80 degrees centigrade, initially the air above it is at room temperature. You close that what you call cover of that thermos, and then after some time open it. What will happen? What will be the temperature above water? 25 degrees रहेगा क्या एयर का?
क्या सर?
If I take a thermos and put water at 70 degrees centigrade, so 50%, fill it up with 50% water. 50% above it is just air. Initially that air above water is at room temperature. बराबर?
Yes, sir.
Right? And then I close the tap or cover, बंद कर दे इसका. Then after some time, 15-20 minutes or half an hour, I open the tap or open the ढक्कन उसका. तो जो ऊपर हवा रहेगा उसका टेम्परेचर क्या रहेगा?
That will also increase.
It will also increase because mass transfer is happening, right? Some water is getting evaporated and going to the vapor phase. That's the only way the temperature will increase. So G of liquid phase is changing, G of vapor phase is also changing. और इक्विलिब्रियम कब होगा? when G of A is equal to G of B. Initially it
Sir,
was
वो समझा है कि यहाँ पे क्या दिया है कि VA माइनस VB है ना, लेकिन
हाँ।
इक्विलिब्रियम है, मतलब जितना वेपर में जाएगा उतना कंडेंस भी होगा, तो VA माइनस VB 0 होना चाहिए ना.
नहीं
वो
नहीं, it is volume, it is not delta V. Volume of A minus volume of B, it is not delta V of A minus delta V of B. और delta V भी सेम नहीं होगा because if you take one mole of water, what is the volume of 1 mole of water?
55.55 liters.
अरे 1 mole of water का कितना
22.4.
18 centimeters, 18 milliliters, right? 1 mole of water is 18 grams of water. बराबर?
Yes, sir.
So it is 18 milliliters of
Yes, sir.
water. It is evaporate into vapor phase. What is the volume of the vapor? What is the volume of 1 mole of ideal gas?
सर वो 22.4 ही रहता है.
Right,
Yeah,
20.4 liters रहता है, right? So जो डेल्टा V है एक वाटर का, it's not even same as डेल्टा V of vapor. It's different. यहाँ डेल्टा V की नहीं बात करें, we're talking about V, volume of phase A and volume of phase B. We're not even talking about delta V. That is not important. What is the volume of A phase and what is the volume of B phase? So because equation में जो है V dP is volume of the phase, it's not delta V.
Yes, sir. Understood now.
Okay. So equation 2 is dP by dt, that is change of pressure with temperature, is equal to delta S by delta V. So change in entropy by change in volume. Now the process is reversible. Entropy change can be calculated with no latent heat of vaporization. Whatever. Because we have seen this for phase change, dq is equal to or ds is equal to dq by t or latent heat upon temperature. ये बताया था पहले आपको मैंने, याद है? So when this phase change, whether from solid to liquid or liquid to vapor, change in entropy is equal to q by t or latent heat upon temperature. If this change of phase is melting, then it is latent heat of melting or freezing, or if it is vaporization, then it is latent heat of vaporization. ये second law से हमने किया था पहले, right? So if you substitute this in equation 2, what you'll get is dP by dt is equal to, we are substituting this here, and we'll get delta H upon T delta V. ठीक है? And that is Clapeyron equation. Any doubts, questions on equation 4? Okay, so if there are no questions, then we can do some simplifications, some assumptions, because we want to have a simple equation which can be used for calculations, right? So we assume that latent heat of vaporization is constant and independent of temperature, which is a very reasonable assumption. And molar volume of liquid is negligible compared to that of vapor. अभी जब देखा, right? 18 ml of water will give 22.4 liters of vapor. So we can ignore the liquid volume compared to vapor volume. And we also assume that vapor behaves as ideal gas. Right? So we we say that delta V is equal to VA minus VB, that is volume of vapor minus volume of liquid. And since volume of liquid is much less than volume of vapor, we can say delta V is equal to volume of vapor, VA. ठीक है, equation 5. Okay, so if you substitute it in equation 4, what you'll get is dP by dt is equal to delta H upon T into VA. And next is we assume that ideal gas, vapor phase has ideal gas. So we can use ideal gas equation for the vapor phase. PV is equal to RT or VA is equal to RT by P. Right? And for vapor phase, if it is vaporization of the liquid to vapor, we can put P is equal to PS, which is nothing but saturation pressure, vapor pressure of component. Right? So if you substitute in this equation, we'll get dps by dt, because pressure is nothing but vapor pressure, उससे ज़्यादा होगा ही नहीं. dps by dt is equal to ps delta h by rt square. Right? We are substituting this VA is equal to delta h by t VA square, VA में RT by PS डालेंगे, तो what we'll get is dps by dt is equal to P superscript as delta h by RT square. Any questions on this? Okay. So if you bring PS on the left hand side, we got 1 upon PS dP superscript s by dt equal to delta h by RT square. And we can write this as dln PS, combine these two. We get dln P superscript s by dt equal to delta h by RT square. And this is called Clapeyron equation. Any questions on equation 6? Okay, no questions, then we'll move forward. So assume again constant delta H is normally constant between T1 and T2. It's not dependent on temperature so much. So what you can integrate this equation 6 from P1 superscript s to P2 superscript s and T1 to T2. So what you get is integral of dln PS from P1s to P2s to delta H by R. You can take out delta H from the integral because it's assumed constant, and integral dt by t square T1 to T2. And integration will give ln P2s by P1s is equal to delta H by R 1 upon T1 minus T2, 1 upon T2.
सर डेल्टा एच किससे कांस्टेंट रहेगा?
Generally constant रहता है. If the temperature is not very different, it's generally constant. प्रेशर पे डिपेंड करता है ज़्यादा, टेम्परेचर पे कम डिपेंड करता है. Okay. Any other questions on equation 7? So now we can use this equation. If we know delta H and we know vapor pressure at one temperature, we can find out vapor pressure at any other temperature. So if you know suppose we know the vapor pressure at 25 degrees centigrade for water, and we know latent evaporation, you can calculate vapor pressure at 40 degrees centigrade. There's the use of this equation. Because vapor pressure हमारे को आगे काम में आएंगे. There is another equation which is used for vapor pressure. कौन सा है वो? To calculate vapor pressure, we use another equation. Do you remember? We have seen this before.
सर वो एंटोइंस इक्वेशन है.
Antoine equation. So Antoine equation में there are constants A, B, and C. So you can calculate vapor pressure at any temperature, right? That is one method of calculating vapor pressure. This is another method. So if I know latent heat and vapor pressure at one temperature, I can calculate at any other temperature. ठीक है, कभी कभी ये भी आ जाता है क्लैशेस क्लैपेरॉन या क्लैशेस इक्वेशन, एग्जाम में डेरिवेशन पूछते हैं. Any other question on what we discussed today? Okay, so there are no questions.